Now let's discuss about prime factorization. See, what is prime factorization? For example, let's take 24. We can express 24 as 1 into 24. This is the one kind of expression. Second one, 24. 2 into 12. See, 2 into 12 is equal to 24. Now 2, we can express 12 as 6 into 2. Okay, this is 2 6 are 12, 12 2 are 24. Okay, here next 24 is equals to 2 into, we can write 6 as 2 into 3. Okay, see here 1 into 24 is 24. 24, 12 into 2 is 24. 2 into 6 is 12, 12 2s are 24. 2 2s are 4, 4 3s are 12, 12 2s are 24. See here, these are the factors of 24. Here expressing of factors in different ways. Okay, see here, if we observe, here we have 1 and 24. 24 is a composite number. Okay, here if you observe 2 and 12, here 12 is a composite number. While coming to the 3, 2, 6. See, 6 is a composite number. While coming to 4, 2, 2, 3, 4. These are all prime numbers. While coming to the fourth one, 24 is expressed as a product of all prime numbers only. So this is called prime factorization. See, we have to express a number as a product of only prime numbers. Then this is called prime factorization. Okay, in this we have two types. One is division method and the other is factor tree method. See, first let's discuss about division method. First, two twos are 4, 2 ones are 2. See, now 21. 2 is not divides 21. So 21 is divisible by 3. So 3 sevens are. 7 is a prime number. See, 7 is a prime number. So it can be expressed as 2 into 3 into 7. Okay, see here we have first divided with least prime number which is possible. Then we move the process on dividing the next possible prime numbers. See, here after we get the end with a prime number, then we have to stop the division. Here what are the prime numbers we got? 2 into 3 into 7. For example, let's take 60. 2. See, 2 3s are 6, 30. Now 30 is divisible by 2. So 2 1s are 2, 2 5s are 10. So 2 15. Now 15. 2 is not dividing 15, 0. So now let's take 3. 3 5s are 15. Here 5 is a prime number ended with a prime number. So this is the prime factors. So 2 into 2 into 3 into 5. These are the prime factors and expressed 60 as the product of the prime numbers. This is called prime factorization using division method. Now let's see factor tree method. Second one, factor tree method. Let's take same 60. See, 60. We have to first express 60 as the product of two numbers. Okay, see, 3 20s are 60. 3 20s are 60. Here 3 is a prime number. So here this side the tree is stopped. Now here 20. 20 is not a prime number. So 2 10s are 20. Okay, here 2 is a prime number. So this is stopped and 10. 10 is not a prime number. So this is continued. So 2 5s are 10. See, here 2 is a prime number, 5 is a prime number. So with this the tree ends. So what are the prime factorization? 3 into 2 into 2 into 5. Let's write in the ascending order. So 2 into 2 into 3 into 5. This is the prime factorization of 60 using factor tree method. Have you understand what is factor tree method? First, we have to express a number as the product of two numbers, and if the two numbers is composite number, then we have to continue the tree. If we get the prime number, that side we should stop, and if one side is composite number, we have to express it as the product of two numbers. Here 2 into 10, here 2 is a prime number, 10 is a composite number. So this side the tree end and it is a composite number, we have to express 10 as the two product of two numbers. So 2 5s are 10. Here 2 is a prime number, 5 is a prime number. So here the tree stops. See, by this way we have to check and we have to write the prime factors using division method and factor tree method. Okay, we have learned what is prime factorization and what is division method and what is factor tree method and how to use these to find prime factorization. Okay, now let's move to the exercise. Now let's move for exercise 3.3. 1. Write the missing numbers in the factor tree for 90. Here 90 is expressed as the prime factors using factor tree method. See, we here some numbers are missing. We have to fill the missing numbers in the factor tree. Okay, here 90, 10 nines are 90. Here 10 and 9 both are composite numbers. So it is continued. 2, 10. Here we have to multiply with number to get 10. So 2 5s are 10. So 2 5s are 10. Here 9, 3. We have to multiply with another number which results to 9. So 3 3s are 9. So 3 3s are 9. First one is done and second one. See, 90, 30. We have to find the another. We have to multiply the number with 30 to result 90. So 30 3s are 90. So 3. Okay, here 30. Here 10. 10 3s are 30. So 3. 10. 2 5s are 10. So 2 5. Here all are prime numbers. So the tree is ended. This is the solution for 2 and this is the solution for 1. Here second one, factorize 84 by division method. See, we have to factorize 84 using division method. See, 84 division method. So we have to start from lowest prime factor. So 2. 2 4s are 8, 2 2s are 2. Now 42 is divisible by 2. So again 2. 2 2s are 4, 2 1s are 2. Now here 21. 2 is not dividing 21 exactly. So 3. 3 7s are 21. Okay, here 7 is a prime number. So here the division stops. So the factorization of 84 is 2 into 2 into 3 into 7. This is the prime factorization of 84 using division method. Now in the third one, write the greatest 4-digit number and express it in the form of its prime factors. See, first we have to write the greatest 4-digit number. First, greatest 4-digit number is equals to 9999. This is the greatest 4-digit number. Okay, we have to express this in the form of prime factors. So we use by division method. So 9999. In ones place we have 9. So it is not divisible by 2. Next 3. 3 3s are 9. 3 3 3. Okay. 3 3s are 9. 3 3s are 9. 3 3s are 9. 3 3s are 9. Now 3333 is divisible by 3. So 1 1 1 1. Okay. See. Here 1 2 3 4. 1111 is not divisible by 3, 5 or any number. Now let's check with 11. Okay, 11 ones are 11, 0, 1. Here we are bringing 1, so we have to add 0. So 1. Ones are 11. C. 101 into 11. 1 ones are 1, 1 zeros are 0, 1 ones are 1. Okay, now 1 ones are 1, 1 zeros are 0, 1 ones are 1. 1, 1, 1, 1. So, triple 1. So, 11 into 101 results to 1111. So, 101 is a prime number. So, the prime factorization of greatest 4-digit number is 3 into 11 into 101. This is the prime factorization of greatest 4-digit number, which is 9999. Now, we move to the last problem of exercise 3.3. Okay, I am the smallest number having 4 different prime factors. Can you find me? Here, he is saying that I am a smallest number and it has 4 different prime factors. Let's write prime numbers 2, 3, 5, 7, 11, so on. See, here he is saying that smallest number. So, product of 4 factors, 4 different prime factors. So, these are the prime numbers and the product of smallest prime numbers leads to the smallest number. So, let's do the multiplication of first 4 prime numbers. Those are 2 into 3 into 5 into 7. Okay, multiplication of smallest prime numbers leads to the smallest number. So 2 3s are 6, 5 7s are 35. Now 35 into 6, 35 into 6, 6 5s are 30, 6 3s are 18, 19, 20, 21, 210 is equals to 210. So this is the smallest number which has the 4 prime factors. Okay, the smallest number is 210. Okay, with this our exercise 3.3 is completed.